Hi everyone, myself D. Sai Kiran. I am working as an assistant professor in CSE department in St. Martin's Engineering College. Today we are going to discuss about the topic that is data structures. So first slide is, so before going into the subjects, first we will see what is data structures. So data structures are the fundamental building blocks of any computer programming language. Okay, they define how data is organized, stored and manipulated within a program. So basically we have a lot of data. So how we are going to store the data into the program, and understanding data structures is very important for developing efficient and effective algorithms. So while we are going to develop any algorithms, first we have to use the data structures to store the data. So first we will see what is data structures. So data structures are the fundamental building blocks of computer programming language. They define how data is organized, stored and manipulated within a program. So first we will have a look into this. The data is organized, stored and manipulated within the program. So understanding the data structures is very important for developing efficient and effective algorithms. So when you are going to develop any algorithms, first you have to store the data. So to storing the data, first the data structures is used to store the data, organize the data and you can manipulate the data within the program. So next point is, the most commonly used data structures are arrays, linked lists, stacks, queues, trees and graphs. So these are the most commonly used data structures. First one is arrays, second one is linked list, stacks, queues, trees and graphs. So third point is, the data structure is not only used for organizing the data, it is also used for processing, retrieving and storing the data. So data structures are not only used for storing the data. So we can manipulate the data. Like what we can do, we can retrieve the data. Retrieve the data means we can fetch the data from the data structure, and storing the data. So we can also store the data into the data structure. That means we can add more number of data into the data structures. There are different basic and advanced types of data structures. So as we discussed, there are many data types. Data structures are there, like arrays, linked list, stacks and queues. So we will see one by one what is arrays and what is linked list. So where we are going to use, in the almost every program or software systems that has to be developed. So when you are going to develop any application, 100% we are going to use the data structures. Without using the data structures, we cannot build a complex applications. So we must have a good knowledge about the data structures. So coming to this, we understood like why we have to use the data structures. Why should we learn the data structures? First thing is, data structures and algorithms are key aspects of computer science. So without knowing the algorithms, when you are going to develop any algorithms, you have to use the data structures for data manipulation, like storing, retrieving, searching, deletion, insertion. So there are so many number of operations. So we'll discuss it in the next slides. Next point, data structures organize and store data while algorithm process it meaningfully. So basically the data structures are used to store the data, that's it. But the algorithms will process it meaningfully. So when you write the logic, what you will write, you will insert the data, you will delete the data, you will update it, right? So you will retrieve the data, you will search the data. So that is nothing but the algorithms. You will do the process for the data which is stored in the data structures. Next one is, learning them helps us become better, more efficient programmers. So if you learn the algorithms, if you learn the data structures, it will be it will give more. You can solve the more complex problems with the efficient coding. So next one is, data structures are essential for advanced topics like machine learning and big data analytics. So if you want to build a more complex applications or software applications, so definitely you will use the machine learning and big data analytics, right? So in order to work on this machine learning and the big data analytics, so basically data structures are essential for the advanced concepts. Next one is, we solve problems faster and more efficiently. So when you use the data structures, it will be very fast and you can implement the code very efficiently. Next one is, many real world and applications are built using advanced data structures to handle large scale data efficiently. So if you are going to develop a small programs like calculate addition of two numbers, right? So you can used with the built-in data types. But if you are going to develop a real-time, real-world applications, so data structures plays very important role. Okay. So next we will see the classifications of data structures. So there are basically two types of classifications. First one is primitive data structures and second one is non-primitive data structures. So coming to the primitive data structures, primitive data types are the basic predefined types of data built into an programming language. So these are like data types, it's a basic kind of data types. For example, if you see like integer, float, char and boolean. So these are the basic built-in data types in the any programming languages. First one is integer. You already know, like when we are going to do any operations on the numbers, so then you will take the data type as int. So if you are going to take any decimal, so you have to take the data type as float. If you are working on any characters, group of characters, like, so you have to take the data type as character, and boolean is like true or false. So coming to the non-primitive data structures, they are more complex structures built from primitive data types. So these are the primitive data types. This is used for only basic kind of programming. But if you are going to develop any complex type of applications, compulsory you have to go for the non-primitive data structures. So what are the examples of non-primitive data structures? First one is, in the non-primitive there are two types are there. First one is linear and non-linear. In the linear we have the different types of data types are nothing but arrays, stacks, queues and linked list. Coming to the non-linear, it is a tree and graph. So we will see how it is classified, how it is classified. So this is complete structure of a data structure. So first, data structure is divided into two types as we discussed in the previous slide. First one is primitive data structures and the second one is non-primitive data structures. So coming to the primitive, we already discussed about integer, float, character and boolean. And coming to the non-primitive data structures, again it is classified into two types. First one is linear data structures and second one is non-linear data structures. So today we are going to discuss about the linked list, but we have to understand how it is classified. Okay, so in linear data structures, again it is classified into two types. First one is static and dynamic. We will see in the next slide what is about static and what is dynamic. So under static we will get the array, and under the dynamic, what are the data structures are there? Stack, queue and linked list. Okay, and non-linear data structures are trees and graphs. So we will see what is static, what is dynamic and what is array and what is linked list one by one. Okay, so I will give one small example about the primitive data structures. You already know, like primitive data structures are like integer, float, char and boolean. So suppose if you want to store any number, so what you will take? You will take a variable and the data type is, you have to mention int because it is a integer number. Next, if you want to store any float values, 2.5 float. So this data type should be float, like same character and boolean. So we will see non-primitive data structures. So as you know, like non-primitive data structures are two types. There is a linear and non-linear. So first we will see the linear. Linear means data is arranged sequentially. Linear means data is arranged sequentially one by one with each element connecting to only one other. So first one element should be there, and this element is connected to the another element. So that is stored in sequentially linear format. Examples we have arrays, stacks, queues and linked list. So when you use these data structures, the data will be stored sequentially one after the other. In non-linear means it's opposite to that. The one element connects to multiple elements. Suppose one element is there that is connected to the multiple elements. But in linear data structure, one element is connected to another element. That's it. But in non-linear, one element connects to the multiple elements with a less structure. So here we don't have any structure, but it follows the structure. It's a sequential format. So non-linear data structures examples are trees and graphs. So for linear data structures, arrays, stacks, queues and linked list. So next we will see what is static data structures and what is dynamic data structures. So we already discussed, like it is classified into two types, like static data structures. So the data structures have a fixed size are known as static data structure. The data structure which is having a fixed size, that means we cannot modify the size of a data structure at runtime, that is called as a fixed size, that is called as static data structures. So next, the memory of these data structures is allocated at the compile time. So here in the static data structures, when the memory is allocated, the memory is allocated for these particular data structures at the time of compilation, and their size cannot be changed by the user after being compiled. So once you compile, you cannot change the size of the data structures, right? So however, the data stored in them can be altered. So you can change the data, you can manipulate the data, but you cannot change the size of the data structure. That is a fixed size. So the array is best example of static data structures as they have fixed size. The main example of the static data structures are arrays. So once you going to develop any program by using the arrays, you have to declare the size of the array before compilation. So suppose you have taken array size of 10, right? So you can store 10 elements in the array. And once you have written that size, defined the initialized and defined the size of array, you cannot change at the runtime. So that is called as a static data structure. They have a fixed size. Next, dynamic data structures. So what is dynamic data structures? The data structures having a dynamic size are known as dynamic data structures. The memory of these data structures is allocated at the runtime. So in the static data structures, the memory is allocated at the compile time, and in the dynamic data structure, the memory is allocated at the runtime. This is the basic difference between the static and dynamic. So here we are assigning the data at the before compilation time. So that's why we cannot change the size of the array. But here the memory is allocated at the runtime. So if you see that, and their size varies during the runtime of the code. So these dynamic data structures size will change at the runtime. Moreover, the user can change the size as well as the data elements stored in the data structure. The user can change the size and as well as the data elements which are stored in the data structures at the runtime. Example of dynamic data structures are queue, stack and linked list. So next, what are the common data structure operations we can perform? First one is insertion. So add a new element to the data structure. Insertion means we can add the new element to the data structure. So this is the insertion operation. So next operation is sorting. Arrange elements in ascending or descending order. So we can arrange the elements in some order, that may be ascending order or descending order. That is nothing but a sorting. So next point is searching. Find any element within the data structure. So if you want to find the roll number of a student in the data structure, so that is comes as the search operation. So you are going to find that particular roll number is present in the data structure or not. Okay, so that is searching operation. Next one is updation. Replace an existing element with a new one. Suppose you want to modify any data in the data structure, so you can update the data by using this update operation. So that is nothing but you can replace the existing element with the new element. Next one is deletion. Remove an element from the data structure. So if you want to delete any data from the data structure, you can delete it. That comes under the deletion operation. So there are basically 5 types of operations you can perform by using this data structure. First one is insertion, sorting, searching, updation and deletion. So these are all the basic operations that you can perform on the data structures. So we'll talk about the linear data structures. The arrangement of data in sequential manner is known as linear data structure. So we are talking about the linear data structure. Linear means arranging the elements or arranging the data in a sequential manner, that is one by one, is known as the linear data structure. The data structures used for this purpose are arrays, linked lists. So already we discussed this point, like we are going to use these kind of data structures to store the data. In these data structures, one element is connected to only other element in the linear form, right? So the following is a list of linear data structures we generally use. Arrays, stacks, queues and linked list we are going to use for this linear data structures. And coming to non-linear data structures, we use the trees and graphs. So coming to the arrays, so first type of data structure is arrays. So we are going to discuss about the arrays. What is array? An array in C is fixed size collection of similar data items into one variable and stored in contiguous memory locations. So it is going to be a fixed size of similar elements. Suppose if you want to store the integer values, so then you can go for the array. Suppose you want to store the 10 integer values in the data structure. So you know like how many elements you are going to store into the data structure. So you are going to store 10 elements, right? So you know the size of the data structure. So at that time you can go for the arrays, because arrays are fixed in size, and before going to develop the program, you know that you only require 10 blocks of memory. So at that time you can go for this arrays. It can be used to store the collection of primitive data types such as integer. So if you want to store, you can store all the integer variables. If you want to store, you can store the characters or float values, anything, right? So but you cannot store like integer and character at the same time. Next point, an array is a list of elements where each element has unique place in the list. If you see example, we have these arrays. So these are like one nodes, right? So elements, we call it as elements. So in the first element, this 2 is nothing but a data. In the second element, we have stored the data, that is 6. In the third element, 11. Okay, these are all the elements in the array. So these are like array elements. And here below, if you see this, array indices are there. Indices means it's an index. So arrays will have the index. So it starts from the 0. The first element is having the 0th location, and second element is having the placed in the first location. So like that, we have the index of these all the elements, that we call it as array indexes. So we can access the data element from the list with the help of location in the list. Suppose if you want to access the second element, so how we will access? You can access by using the index. Array of 0 means it will return the this particular element data, that is it will return the 2. So like that, it will, you can access all the elements by using the index of an array. So coming to the next slide. So what are the advantages of an arrays? So efficient memory usage. So your memory is not getting wasted, right? Suppose you want to store in 10 elements. So what you will declare, the size you will declare as a 10. So the memory is not getting wastage here. So that is a efficient memory usage. Easy implementation. So it is built-in language functions are already predefined functions are there. So it is very easy to use the arrays. And versatile operations like sorting, searching and other operations, you can use it. Next one is random access. If you want to access any element from the arrays randomly, so you can access by using the index of an array. So next point, what are the limitations of an arrays? So fixed size, this is the main drawback of an array. Suppose I am want to store 10 elements now, but at the runtime, if I want to store more number of elements, it is not possible by using this arrays. That is the drawback of an array. Index out of bounds exception. So if you are trying to access any element out of the range, like suppose you have 10 elements, but if you are accessing the index of 12, right? So you will get the exceptions like index out of bounds errors and inefficient and insertion and deletion. So arrays, basically if you want to search, you have to use arrays. But if you want to insert or delete any elements in the arrays, it requires lot of shifting elements. So it's a limitation of a arrays. Next, coming to the next slide. So linked list. So there are mainly 3 types of linked list. What are they? Single linked list, double linked list and circular linked list. So we are going to discuss about the single linked list. So what is single linked list? So this is the logical representation of the single linked list. So first we will see what is the definition. Since in a single linked list, each node contains a reference to the next node. So these are all called as a nodes. Suppose I have the first node. In this node, I have the data part and the next part. This entire thing is called as a node. Same, I have like multiple nodes here, and one head is there. So this head is pointing to the first node, and this node contains 2 parts, data and the next. Data is nothing but the actual data what we are going to store in this data structure, and next is nothing but it is a pointer which is pointing to the next node. Like that, each and every node is connected with this next pointer. Okay, and the last node doesn't have the next node. That is why we are placing it as a null. Okay. So these are all the operations you can perform by using the single linked list. You can insert, you can delete, you can traverse. Traverse means like you can iterate one by one element and you can print it. That's nothing but a traversing and single linked list. Search, you can do the search operation, right? So we'll see one program. So how to develop a program by using the single linked list. Hmm? 12 minutes. Yeah, we complete. No problem. With video అంటే నేను ఇచ్చే డెమో ఇదే వీడియో ఇంకా Okay, start. Huh? So we'll see one example how to implement. Suppose I have a head here. Okay, so head is nothing but a pointer, as I said, right? So head is pointing to the first node, and this node, this is the logical representations of the single linked list. Suppose we'll take three nodes. Head is having the address of the first node. This is nothing but a address of this first node. First node address is 100. Let us assume like second node is having 200 and third node is having 300. Okay, these are the address of this each nodes. And first section of this node is a data. Suppose I am inserting 8. Okay, so this next is nothing but address of the second node. That means 200. So when you have this address in this particular position, that means this node is pointing to the another node which is having the address of 200. Suppose I have 900 and here 300, that is address of the next node, and next here some 6 is there. Okay, so here we will have a 0 or null because I don't have the next node. That's why we are keeping it as a 0. So how we will implement this? Okay, so before going to implement this one, first we have to define the structure of our node. So in C language, to define our own structure, we will go for the structure. So struct is a keyword. Okay, so define the structure of a node. So this is a node, right? So I am going to define my structure. So what is the structure here? First one is data part. So I am storing integer type of data. So I am taking data type as int, and here data is a variable. Okay, I am taking one variable, that is data. It's a type of integer. Next one is I am going to take this pointer. Node is nothing but a pointer which is pointing to the another node. This node is also type of struct node. So that's why I will take struct node asterisk next. So this is the next is a variable. This is a pointer which is pointing to the next node. This is my structure of the node. Now coming to the implementation, we will try to implement this one. First I want to create one node. Before that we will declare the head. So head is also pointer, right? So which is pointing to the node. So that's why I will take the type as struct node asterisk head. So here I am declaring the head pointer. So initially what we'll do, initially we don't have any nodes, right? So that's why we will take head equal to, we'll declare head as 0, right? So next I want to create a node now. So first what we did, we defined the structure of our node, that is completed up to here, and next we are starting the from head onwards. Head always pointing to the first node. We should not move the head to the another nodes, because if we move the head to the next node, we will lose the point to this particular node. So we will lose the data. So we should not do like that. So that's why head always should point to the first node. And next, in order to create a new node, what is the function? In C, if you want to create any dynamic memory, we will use the malloc function. In the malloc function, we will have size of method where we will pass this our struct node. So we have the define the structure, right? So we have to pass the struct node to the size of function. So when you pass this, what will happen? This malloc function will create a memory of the struct node. So what is the memory? Suppose int, it will take 4 bytes and this pointer will also take 4 bytes. So total 8 bytes memory will be allocated, and this will return the pointer, okay, address of the newly created node. It will return the address of the newly created node. Suppose when this line get executed, what happens? One new node is created, right? So this new node we should hold with the pointer. That's why I'm taking new node. So here we define the new node pointer. Okay, so basically it will have some address, right? So suppose assume it is a 100. Okay, it is having the address of 100. So after this, what we have to do? So we have to, a new node is created, right, which is pointing to this node. Okay, so after that we have to ask the user to enter the data. Now we have to fill the data and the address of the next node. So before that, what you have to do? we have to make, to ask the user to enter the data, we have to write printf enter data. So here user will enter the data. After entering, how we need to read the data? We have to use scanf to read the data. So what type of data is entering? We are expecting integer type of data. So we'll take, and now we have to store the data in this part. Suppose he is entering 8. So we have to store 8 here. So how to access this one? With this pointer we have to access. New node of data means this section. New node of next means this section. So we can access this particular section with the help of this pointer, ampersand of new node of data. So whatever we are reading the data from the command prompt, we are assigning to this new node, right? So after assigning, next here there is no new node, right? So this is the only first node which we created. So here what we have to keep? Definitely we have to keep 0. So how we'll keep the 0? New node of next. New node of next equal to 0. New node of data means this one. New node of next means this one. New node of next is equal to 0 means here we will keep 0. Now head should point to this newly created node. So it should be like this, right? Head should point to this newly node. So if I want to point to this to particular new node, what is the address of this new node? 100. So if I give head as 100, then it will point automatically to this newly created node. So how we will define that? Head equal to new node. So whatever the value of this new node, it will assign to the head. So that head will point to this newly created node, right? Okay. Suppose I want to create one more node. Okay. So if I want to create one more node. So when one more node is created, again we'll ask the user to enter data. Now what happens? The new node is pointing to the newly created node. Now new node is point to this newly created node. So what is address? Suppose assume 200. Okay. So 200. So how we have to update the head of next? How to update the address? Head of next equal to new node. What is the new node value? 200. So head of next means this one. So if you head of next equal to new node means, head of next equal to new node means new node value we are assigning to the head of next here. So if you update here, it will point to this newly created node, and in meanwhile the user will enter the data like 9, and here it will be 0. Understood? Yeah, so this is about the how to implement the single linked list. So I hope you understood about these data structures, why we need to use data structures, what are the data structures, and what is single linked list, and what are the advantages and disadvantages of arrays. Yeah, thank you for listening the session. Thanks.